Okay, welcome. I think a couple of months ago I asked to give a presentation here, and PHP Amsterdam invited me to give a presentation, so I had to think up a topic. And one of the things that was bothering me always was that we had many applications at Copernica that were slow, and all the times we were thinking, well, we can speed them up by porting them to C, but porting an algorithm or a data structure to C is really difficult in PHP. So that's why I decided to make a library to make it easy. And that's what I'd like to have a talk about. About myself, I'm the founder and partial owner of Copernica, the company that you're now, that has invited you here. A long time ago, I've studied computer science at the Vrije Universiteit here in Amsterdam. And I've been a PHP programmer for, well, quite a long time, since the PHP 3 times, and a C++ program even longer, since 1995, since I was at university. Last year I've initiated 2 projects, MailerQ and PHP-CPP, so these are the most recent projects that I've been working on. And if you'd like to see more about MailerQ, go to mailerq.com. And if you want to know more about PHP C++, you can now listen to me. What I'd like to talk about is why you should go native in the first place. Then I will give a small tutorial about how the PHP C++ library works, what possible alternatives are for this library, and well, I will have try to get to start a discussion if it is wise to use PHP, and in what circumstances you should use PHP, and in what circumstances you should use native. And this PHP C++ library is an open source library. We have opened the source, and I will explain why we have done that, because that's for our company a very new development. If there are any questions, please feel free to ask them, and please feel free to be critical, because this is the first time that I'm giving this presentation. So it's also for me quite challenging, because this is the first time that this project is going public, and I'm explaining this project to, I'm telling about this project to the world. So if you have questions or want to be critical, please do. That's only helpful for the project. I'm going to start with a little screen capture that I made. Let's put that on pause. We are looking here at a small PHP script. It's called bubblesort.php. And bubblesort is an algorithm to sort an array. It's not a very good algorithm. It's quite slow, and there are a lot of algorithms that are much better, like quicksort or the sorting algorithm that's built into PHP. This is not an example of a good sorting algorithm. The only reason why I made this script is to show you an example algorithm to show how fast or how slow PHP is. You can see the algorithm, which loops through the array twice. And it creates an array of 10,000 random integers, and it calls bubblesort to sort that array. Let's run it. And now we wait. 8.7 seconds. Wow. Maybe you were not paying attention in those 0.3 seconds time. But what we did was, basically we wrote exactly the same algorithm. The only thing that we changed was the signature of the function, and we removed the dollar signs. This is C++ code. It is almost exactly the same as PHP code. And where PHP code takes almost 10 seconds to run, this C++ code, you can compile it within a split of a second and you can run it in a split of a second, and it's much faster than the PHP code that you saw. This is native code. It's 10 times as fast as PHP code. And the same algorithm. There are very good reasons to go native, to use native code. It is much faster. You've seen it, you can get speed improvements of 10 times. And the memory consumption is much better. You saw the algorithm that we just ran in PHP. It created 10,000, an array of 10,000 entries. It takes about 10 megabytes of memory to create that array. That's a lot for only 10,000 numbers. The C++ program only takes a couple of kilobytes. PHP is slow and it takes a lot of memory. And there's another good reason to use native code. Native code is much more accessible from other languages. Let's talk about performance. I think we all know how important performance is. Think about the Google Spider. The speed of your website is important for your indexing in Google. Fast websites get higher search results than slow websites. But that's not all. Google is smart, and they are nice to us developers. If Google notices that a page takes a lot of loading time, they are nice to us, and they will not fire their spider. They will not start the spider with 10,000 of requests because they know that our website is slow, so they index slowly, they spider slowly. But if they notice that the website is fast, they can index the website, and the spider will visit you, will generate a lot more visits to index your website. Especially if you have a big website with many pages, dynamic pages that change all the time. If it is fast, it will be indexed much faster. And Google will be more up to date, and Google will index more pages of your website. Also, if your programs are faster, you can handle much more requests with one server. If you have a website that serves millions of requests per day or per hour or maybe even per minute, it takes a lot of servers to handle that with PHP code. If you can run that natively with almost the same algorithms, only the dollar signs removed, you can save 90% of your hardware costs. Imagine you have 100 servers and you can throw away 90 of them. That's a lot of value that you can save. What you should also consider, if you have the last point on this sheet, if a script takes, for example, 1 second, the first thing the script does is connect to the database. Then it runs a query, and then it starts the algorithm. After this 1 second, the script finishes, and only then the connection to the database is closed. So the connection is open for 1 full second. If you go native, the script will run only for 1/10 of a second. So the connection to the database will last a lot shorter. So the load on a database, the number of open connections to the database, will be less too. So speeding up your programs, speeding up your algorithms does not only save you time on your web server, but also on your back-end systems, also on your database, also on your storage systems, also on all the other systems that you have. Speed is that important. One other big advantage of native code is that almost every programming language that there is has bridges to native. PHP has all these extensions that call native libraries and native functions. Other languages do not have that. Imagine that you have developed a certain algorithm in Erlang, and suddenly someone comes along and you say, well, we have a technology in Java and I want to access with Java that algorithm that you made in Erlang. That's difficult and possibly requires you to start up separate programs, to parse input, to parse output, just to call a certain function in a certain other language. That's difficult. A native implementation is the most easy implementation to port to any other language, because almost every language has built-in support to call C libraries and C++ libraries. So if you have an algorithm, or if you have a data structure or some business logic, and you need to decide what language should I choose to implement this in, it is a very good idea to implement it in C or in C++. That's easy to access with other languages, much more easy than it is to access the same algorithm written in, for example, PHP. But is there still a reason to use PHP? Yes, there is. PHP is a great language as a template language. It's a great syntax. There is no language so easy to start developing websites with. If you want to create a dynamic website and you have an HTML file and you want to turn that HTML file into some dynamic content, you only need to change the extension to PHP, and suddenly you can start writing software. You can start adding algorithms. It takes only the extension that needs to be changed, nothing else. Suddenly you have access to an extremely powerful language with all the concepts that a normal programming language has too, and you can start making software. It's very easy to deploy. It's just a matter of a PHP file. Just as simple as you can add an HTML file to your server, you can add a PHP file. It will work right away. It's easy to deploy. If you make a mistake in your PHP script, the worst thing that can happen is that the error log file on your server shows a notice. Fatal error in line this on that specific script. Easy to debug and easy to handle. And the white screen of that. And the white screen of that. But if you program natively, the worst thing to happen is that Apache shows segmentation fault, memory violation in memory address, who knows, core dumped. We have the same problem with PHP. They have core dumps as well. But if you program natively, if you make a mistake, you have a core dump. It's so hard to debug, to find the error. It's difficult. And PHP is so easy to debug because it shows exactly the error in the log file. And I've been visiting this PHP Amsterdam meetings for, I think, half a year or so, since a couple of months. And most of the meetings are about software structure and about design and about architecture. And that's true. PHP is such a nice language to make really good-looking software. And if you take a random C or C++ project and you dig into the code, it is so complicated and it's so difficult to understand what those programmers are doing. And if you take a look at PHP projects, a lot of times you will find projects that are well documented, have a well designed, have a good structure. Not always, of course. And of course, writing code for PHP is much simpler than writing code natively, although that's what most people think. But that's not really the truth. Building extensions for PHP is difficult. If you have a PHP script and you look at the statistics and you look at the profile and you suddenly notice that one specific algorithm or one specific function takes up a lot of memory usage or takes up a lot of CPU power, you think by yourself, oh, we should port this to a native implementation. We should change this algorithm into a C algorithm. And how do we do that? The truth is there is no documentation on this. This is a blog article on the Zend developer zone. It's from 2005. And this basically is the most important article, in fact the only article that somehow explains how to write a PHP extension. This is written by a girl, she's now working for Facebook. She also wrote a book about it. This is a book from 2006, and this is effectively, Sarah Gum, indeed. This is essentially the only book about writing PHP extensions. We have a lot of books about everything, but about PHP extensions, there's only one, and it's from 2006. This is the Hello World explanation, how to write a Hello World application in PHP C link. It's a very long article. Memory management is difficult. Hello World. This is how it is done in PHP. Well, they had an HTML problem on this website, but I think you have an ID. We need to start with some config.m4 file. It's not really clear how to use it and what to do with it, but okay, let's just copy it and hopefully it works, and some fake syntax, and okay, let's hope that it works. And then we need to make a header file with also things that are not so easy to understand, and a C file with some structure with all null pointers, and we don't know what it is doing, but we trust them that it is correct. And okay, and the hello world string, of course, which a comma 1, which means something, but we don't know exactly what it is. So there we have our hello world program. So we have a long article, how to make hello world. It's complicated, difficult to understand, and the article goes on and all the how to make it and how to build it and some examples. And this is just hello world, how to program hello world. It's complicated. Okay. Okay, what's next? This is hello world, but you want to handle variables in C as well, of course. The next section. This is about variables. And a PHP variable, it's not typed, so you can use an integer or a string or an object or an array. You can put everything into a PHP variable. In C, it is more complicated than that because every variable has a type. So when you assign a number to a variable, it cannot be used as a string from that moment on. So PHP has a structure. Let's see where it is. So this article explains how variables work in PHP. Let's see all the different types of variables. And this is the value object that you need to understand if you want to write PHP extensions. It's difficult. It is some structure that can be a long value or a double value or a string or a hash table, which is used for arrays, or an object value if it is an object. You need to keep track of the references, the number of references. Every time that a variable is assigned, it uses copy on write semantics. So if you have one variable that is used, you can use one value with many variables, and only at the time when you change it, you need to split it and to change your ref count. It's difficult. It's complicated. You don't want to do that. So writing such programs is not so easy. It explains how to access arrays. How to access. All these functions are for accessing arrays. In PHP, it only takes a square bracket. In C code, it is so complicated. Okay, I hope you get the point. And this is essentially the only blog article about how to make C extensions for PHP. There are some other articles, but they are outdated. This is the best article there is. And this is the best book there is. It's from 2006, so many topics that are now in PHP are not even covered. But it's the only thing that we can use as extension writers to make native extensions. And because there is hardly no documentation, as an extension developer, there is nothing else to do than look at the header files and look at the source code itself. So take a look at the header file of the Zend engine. And this is not the only header file. There are about 100 of these files that contain the entire Zend engine and all the functions that are accessible with it. It's complicated. And there is no documentation in it. I think if you would write such functions in PHP and you would submit it to any repository or any library, they would not even pass code review, even if it is working. Who cares? It has no structure, no documentation, classes with many different variables in it. We have no idea what it does, no documentation, how to use it, we don't know. These are all the functions, and there are 100 of these files that explain how the Zend API works. It's complicated, it's difficult, and it cannot really be used in a business context because you have colleagues and you make code, and tomorrow someone else is going to maintain your code, and next year a future colleague that you do not even know today will need to change your code because an extra feature is added. And if you're using this, it is difficult. And these books and these articles are not even covering classes and objects. And if you're writing software, classes and objects are very important. That's the most important element of a language if you want to write object-oriented software. Oh, I'm skipping one. So I've been writing this C++ library, and I wanted to add classes and objects to the library. And because it's not documented, I had to dig into the PHP source code to see how it is done. How do you create in C a class, or how do you create an object in a PHP script in C? And I was thinking, well, there is no documentation, so the only thing that I can do is dig into the source code and look at an example. And I was thinking, what's the most simple, the most straightforward class that there is in the Zend engine? And I was thinking about the date-time object, which is very straightforward. It's just a date. It cannot be more simple than that. So this is the date-time object in C. It defines a lot of things and macros and
there goes the L and if Windows on it.
it's complicated. Well, just take a random point in this file. It's about pointer manipulation and pointers to pointers, and if you dig into the code, you even see variables that contain a memory address where, and in that memory address there is another address to some other piece of memory where you can redirect from. It's almost impossible to understand. It's really surprising that a language that is so well documented on PHP.NET has such a chaotic structure internally. And that's what I want to prevent with the PHP C++ library, because writing native extensions should be simple. And that's why I invented the PHP C++ library. This is what hello world looks like if you use PHP-CPP.h. It's only really one line, one function. It returns a PHP value object, which is, well, basically a PHP variable. It can be a string, can be an integer, can be an array, can be an object. And this time we return the string hello world, and the PHP value object, which is a C++ object, automatically converts that string into a valid PHP value object. It's that simple. And what we need to do when we compile this file will be turned into a .so file. And I don't know if you have been working with PHP extensions, but you have them in the php.ini file. You have a list of all the extensions that are loaded, and their whole extension is myextension.so. And when PHP starts, it first loads that php.ini file. It loops through that list of extensions, and it opens each .so file. And in each SO file, it locates the getModule function, and it calls that getModule function. And that getModule function should return a memory address that points to a structure that holds all the properties of that extension. That memory structure needs to have all the functions that are defined by the extension, all the variables, all the constants, everything that's defined, all the class, everything that's defined by that extension should be at that memory address. So when you write a PHP C++ extension, you need to implement that getModule function. And it is a very simple function. All you need to do is create an extension object with the name of your extension and the version number, and you need to add all the functions that you have implemented in C++ to that object. So we have only one function, our function is called hello world in C++, and we also want to call it hello world in PHP code. And what we then do after we have added all our functions, we can return extension.module, which will do everything for us. It returns the memory address where the structure is that holds all the information about this module. It is that easy. Working with parameters is just as easy. If you create a function, which is, for example, called myPlus, and myPlus takes an undefined number of parameters, and it sums them up. It's an easy function. It takes one argument, which is an object that contains all the arguments passed to that function, and it sums them up. And because of C++ operator overloading and casting overloading, we can, the result object, which is an integer, will automatically be added by the specific parameter. And just like we did with the Hello World application, we did do that the same with this application. We create the extension object, we add our myPlus function to it, and we call extension.module to get the memory address that holds all the extension details. And after we have done this, we can write a PHP script that calls myPlus like this. That's simple. Only one file to build everything.
What happens if you put in strings or arrays?
Oh, if you want to handle string, you can do so just as easy.
Will this give a nice, will this cause a nice exception?
No, it will not trigger an exception. It will behave exactly as PHP does. So if you pass in a string, it will be converted into an integer, just like a PHP string is converted. So if it turns out to be a string that contains a number between, so it's interpreted as a number. If you treat an object as a string, it will even call the underscore toString function to convert that string, that object into a string. Arrays, right? Yes.
What happens if your class is your client to that function has not implemented the toString function?
I believe it then returns a string object, just like PHP does.
Which will be converted to 0.
Which will be converted to 0, yes, exactly. Working with arrays is just as simple. The value object, which is a PHP, which is a C++ object, has implemented operator overloading for the square bracket operator. So you can also treat it as an array. So we have we've changed the sum function into a create array function, and it just creates an array, and it's that simple. If you do it like this, I've left out the glue code now to export a module. If you make a function like this, export it in your module, you can just call it like this, create array 3, 4, 5, and you get this specific array. It's very simple. Working with classes and with objects is also easy to do. Imagine you want to write a class in C++. You can do it like this. You make your own class, which you call myClass. You need to override the base class of the PHP C++ library. And in C++ you do it like that. You create some private members, you can create a constructor, and you can create a method. And you want to make this class accessible in PHP. Like we have seen with the other examples, we also create the getModule function here to export the memory address that holds all the definitions of this extension. We create the extension object with the name myClass and the version number 1.0, and we add our PHP, our C++ class to it. I am not completely happy about the current syntax of this, because you have to specify myClass 3 times, and I think that's 2 times too many. But I have not yet managed to make that easier than it is now, but I'm doing my best. But still, it's quite simple to create this class to make this class accessible in PHP. And after you made this, this file and you compiled and you added it to your php.ini, you can create a PHP script like this. You can create an instance of your class and call the total function on it. It's that easy. You can even use the class that you defined in C++ as a base class for your own extended class. You can override the total function and call the base function and multiply it by 2. So this is a PHP program that uses the C++ implementation. And it is that simple. So we have seen that this library is a layer between the Zend engine, which is complicated and difficult to work with, and offers a very easy way to build your own C++ native functions and use them in PHP. And we had a number of principles for making this library. The first principle is that building native extensions should be easy. It should be simple. It should not be so difficult as it is now. It should be a simple thing to do. And another objective of this library is to hide that Zend engine. We don't want professional developers build almost impossible to understand source code like the current extensions are. If you want to write native extensions for PHP in an enterprise environment, it must look good. A colleague must understand your code right away. And that's what the target of this library is. We do not try to be feature complete. The goal is to have an easy to use library and not to cover every thinkable feature that we have in PHP. Some specific features like closures and callback functions and functions returning references to variables, they are complicated features and they do not need to be in this library as long as we can make a library, we can offer a library that is easy to use. And you can compare the PHP C++ library to jQuery. Just as jQuery is a very easy to use library to create JavaScript and access the document object model without having to go into all the details of the specific browsers and the complicated stuff that all those browsers and the document object model has. You can use jQuery, which has a very clear syntax, which is well documented, which works, which everyone's making software for. And PHP C++ intends to be the same. It intends to be a library that's really easy to use, and that's much faster than writing the same thing, the same algorithm in PHP. Are there any questions up to now?
Okay. What about interfaces and newly introduced traits, generators, the new features from the PHP 5.4 and 5.5?
Yeah, that's a very good question. We have not yet implemented interfaces, and the generators, we have not yet implemented them too. So that's a very good question, but we can add them. We can add them. Of course we can. Hmm? It depends on the community, because I have other work, of course, too.
Is this an open source project?
This is an open source project. It's on GitHub, and everyone can join.
What about the support of currently popular tools like Composer or the frameworks, major ones like Zend or Symfony? So is this translator supporting the features like reflection API, which is widely used by the frameworks, or it's only suited or only tailored for speeding up your internal infrastructures?
We have not yet implemented reflection.
I think, may I?
Yeah, of course.
Well, continue where he left. I think the question really is it possible to access this PHP classes like the SPL interface there in C++?
You can call functions from PHP from C++, but the real reason why to use this is because you don't want to use PHP. the first thing that you want to do when you write a PHP script, you can compare native code to a highway and PHP to secondary roads. And the first thing that you want to do, you get your index.php and you want to get away from that secondary road as fast as you can. And you want to go to native code and run fast, run natively. So if you are going to call from your native code back into PHP, that's not a very wise thing to do. You want to be running native because that's fast. That's 10 times as fast and takes 10 times as less memory. But you can. We have already implemented that you can call functions, and we will implement that you can call methods and all the objects that there are.
Is it possible to access the functions described in the C sources of PHP?
What do you mean?
Well, sometimes you want to use one of the core functionalities that are being written in C.
Yes.
And you want to implement them to extend functionality or whatever. Is that possible?
That's a very good question too. That was not the design of this library.
Okay.
We want to hide the functions of all the Zend. We want to hide the complete Zend engine.
Yeah.
So you're asking, can I call one specific function from the Zend engine directly? Yes, that is possible, but that's not the intention of this library. We want to hide that for you.
Right.
But if you do make a program that includes not only PHP-C++.h, but also the Zend header files, you can call those Zend header files, of course.
Okay.
But that's not the intention of the library. The intention is to hide that complicated Zend engine and to just offer this simple API.
Okay. How many extensions have been written on this tool already?
0.
It's just introduction.
Yeah, this is the first introduction of this this library. Yeah. Yes.
What's your reasoning for, from your own company's perspective?
That's in fact the very last sheet that I have, but there are a couple of reasons. Let's talk about alternatives, because I have been talking about this project with some other PHP developers, and they've asked me questions, but what's the difference between what you're doing and what, for example, Facebook is doing? And what's the difference between your project and Falcon PHP? So I will try to answer those questions. Do you know the Facebook hip-hop HHVM project?
Yeah.
What they are basically doing is making an alternative for the Zend engine. They have a just-in-time compiler that turns your PHP code into C++ native code, and that compiles it and that turns it into a binary. As a developer, you can still write PHP code, and instead of using the normal Zend PHP application, you use the Facebook HHVM application. It's faster. It's a couple of times faster than Zend, so it's a very interesting project, but it's still not as fast as native. If you're writing native code, of course you will be faster than if you write PHP code and have some external program turn that into native code. It's doing its best, but it can never be as fast as writing native code directly. And if you're making important algorithms and important data structures and you're still writing PHP code and you try to access it with Java or with another C++ application, it's still difficult to access your own code. So it's a very cool project. It's a very good idea to make PHP faster, but because it can be much faster. The current implementation of Zend is not as good as it can be. But you're still writing PHP code.
Will they work together?
Hmm?
Will they work together with your project?
I don't know. I don't know what they do with the current extensions.
Why are they not just writing their code in C?
What they are saying is, well, we have a large team of PHP developers. We have hired all these PHP developers who can write PHP scripts. We like that because Facebook saying PHP is a good language. We can hire a lot of developers who can write PHP code. So we want to keep doing that, but we want to make it faster. And we think that we can do a better job than Zend is doing. So we still want our team to make PHP software, to write PHP algorithms, to write PHP scripts, but we execute them much faster than the Zend default engine is doing. And in my opinion, if you really look how easy it is to make native code because it is not much different than PHP, because you remove the dollar signs, you change some names of variables, and that's basically it. So it is not difficult to make native code. I think that writing directly in C++ is more interesting than this. And in fact, I think that Facebook at this very moment in time is doing the same thing as I am doing now. So we are maybe competitors, but of course, I think
it's a scalability issue.
I think that in the end, I will win this.
What's the prize? Yeah.
I don't know. Now, the fact is, I sent a tweet to the girl who wrote this book in 2006, and said, "Look at my project. I'm doing this." And she tweets in my back, "Well, I'm doing exactly the same now." So that's a real. I'm an open source project there.
I can think of one issue that could be a problem, and that's deployment.
Yeah, that's a good question, because you need to compile it first.
Yeah.
So
you need to restart Apache, maybe.
Yeah, that's true. That's true. You need to compile it first. Yeah. Deployment of native code is more difficult than deployment of PHP scripts. That's true. So it's harder to deploy a native application, and it's also much harder to debug it. So there are many reasons to work with PHP. Do you know about the Falcon PHP project? This Falcon PHP framework is just another framework, just like Symfony or like Fuel or like Cake or like Zend or like many of all those frameworks that are out there. And the main difference between this framework and the other frameworks is that they have decided to implement it completely in C. If you look at the Symfony source code, all Symfony files are written in PHP. And they have decided to write all their functions and all their classes in C. So it is much faster. They have a graph on their website, and that shows that they are indeed 10 times as fast as all the other frameworks. And that's because they are native. So it is much faster. So if you're ever in the position that you need to choose between a framework, and should I choose Symfony, or should I choose Zend, or Cake, or Fuel, what should I use? Take a look at this project, because it is native. It's much faster. It takes a lot less memory, and it runs much faster than the other framework too. It was built in C. But if you're using that framework, you're still writing your own code in PHP. So if you're making a complicated algorithm and you're using Falcon PHP, the framework will be fast, but your own code will still be slow. And what they now experience is that because they've written their entire framework in C, they experience that it is difficult to maintain. If you're using, for example, Symfony, and you encounter a bug or a missing feature, you can just, as a PHP programmer, open the Symfony source file and change it and submit it to the project maintainer and ask them to include your change into the core distribution. That could be, yes, that could be. But they experience that with Falcon PHP, because it is written in C with the Zend engine API, it's really difficult. There are not as many programs that like to contribute to the Falcon PHP, because they look at that code and say, well, this is a mess and I don't understand it. It contains pointers to pointers to pointers. I'm not going to burn my fingers on that. So the core development of this library is complicated, but still it's a very fast library. And what they are now doing is they have invented a new language. They are saying, well, because it is so difficult to write our Falcon PHP extension, we have created a new language, which we call Zephyr, which is some language between PHP. It's a little more complicated than PHP, but more simple than C. It's somewhere in between. And I don't think that this is a very wise idea, because there are already so many languages in the world, and you can do the same thing with C++. So why invent a new language for us? But maybe it will work. I don't know. But this is a very interesting project. You should have a look at it. Another interesting project is Swig, which is in fact very old. It exists for a long time, and it's a sort of tool that you can use to convert your native implementation into a PHP extension, or a Perl extension, or a Java extension, or almost every programming language can be targeted with Swig. So if you write a C++ function and you want to turn it into an extension, you can call Swig to convert your C++ function into a PHP function. The downside is that it works only for quite simple functions because they have to support all those different languages. They only support the basic elements and the basic features of a language and not the complicated things like classes and objects. But it is very interesting as well. Okay, I'm coming to the end. What would be the perfect world in my opinion? PHP is essentially a template engine. You have an HTML file and you turn it into a PHP file and suddenly you can start writing functions and if statements and while statements and loops and things like that. But it should only be used as a template engine. It should not be used as a full-blown programming language. The moment you find yourself making classes, making large object structures, making complicated algorithms in PHP, think native. Native is so much faster, and with this library, it is so simple to write the same algorithm in C++ as you're doing in PHP. All your business logic, all your data, it should be native. Native is faster, and you can also access it with many other languages. I think this is the way to go. Use PHP as a template engine, use PHP as the next version of Smarty or the next version of any other template engine that there is, and make all the complicated classes and objects and algorithms natively. It's so much faster, and it is basically exactly as difficult to do.
How far would you go with that? Instead of writing PHP, you write native? To the point where is it just better to lay in a service layer and write everything else in Python or Java? Or something that performs better?
Well, I wouldn't write anything in Python or Java. If you're writing in PHP, PHP is a language that is so close to C++ and C. If you are already writing your software in C in PHP, move it to C. It's just as difficult.
You would say that the barrier to go to C++ would be easier than moving to a completely different language.
Yeah, and C++ is much faster. There's no reason to go for a different language. C++ is the fastest language there is. Well, maybe assembly or so, but C++ is extremely fast compared to PHP. Of course, if you can use assembly as well, if you like. I would strongly advise against it. Yeah.
You think it would take a lot of effort to create something that could automatically generate it from the PHP code, the extension?
That's what the Facebook guys are doing. But if you convert it automatically, the software that.
I mean, you have PHP code.
Yes.
And you say you remove the dollar signs, and then you have more or less C++ code. Would there be something useful?
Yeah, that's what Facebook is doing. That's what Facebook is doing. They are.
They're doing it on the fly.
Yes, they're doing it on the fly. But if you use C++ directly, you are forced as a programmer to think about your algorithms, and it is so easy to create a variable and that you assign an integer to it, and 5 lines down you assign a string. And when you do that, you make things slow. You don't realize it, but it is difficult to convert it. And when you start writing in PHP, when you start writing in C++, when you start programming natively, you immediately realize the importance of performance. Your whole mindset changes the moment you create a file which you call myclass.cpp. The moment you create a file like that, everything changes in your mind. You know performance matters. So the final words of today. This is an open source library. For Copernica, this is the first time that we have created an open source project. And why have we done that? Because we have been hosting this, we have hosted this same meeting a couple of months ago, and you gave the presentation about open source, how cool it is, and that the whole community is going to contribute to it, and that you start the project and suddenly you have tens or hundreds of programmers who are starting to contribute to your project. We have, well, I say zero, but there's one contribution from the community. Someone made the change to the README file. So
That's the first.
yeah. Yeah. So I would like to have this community working for us and to make this a cool project, started from PHP Amsterdam, started from Amsterdam. I think this is potentially a project that could change the PHP world. It's also a showcase for Copernica. I want to show this is my company, and I want to show, well, this is what we are working on. This is what we like as programmers. We like making software like this. We like to do new things, and we like to invite everyone. If you think, well, this is a nice project, this is a nice company, we have a number of flyers lying on the table in the bar. Take a look at it if you're looking for a new job, or maybe not today, but maybe some time in the future, and you like to speak with me or speak with any of my colleagues. Please feel welcome. This is my final sheet. So wanna help? Want to see more information about this? Go to PHP-CPP.com.
Sorry.
Okay, I think we're done.